Hello everyone. We'll start in some time. I'm just waiting for others to join. Probably in 5 to 10 minutes. Hello everyone. So my name is Adarsh Kumar Ruma. So I'll be a TA for this course, and I'll be taking weekly lectures every week. And meanwhile, I would like you guys to introduce yourself so that we know who all is there. So maybe one by one, you guys can unmute yourself and probably start introducing yourself. So any one of you can unmute yourself, and can you just introduce yourself? you can write in chat also, just your brief introduction from where, what you are studying, where are you from, those things. Am I audible? Okay. So since there are not many people, I request all of you to introduce yourself one by one, if possible. So it will be better if you guys interact, because if you have any question you need to ask anyway. If you're not interacting, it will not be very effective. This live session, you are anyway having these live, record lectures. So unless you interact, it will be difficult for you to understand, and it will be difficult for me as well to understand what problems you are facing in during your course, which we can resolve. So I suggest you guys to interact during the class, okay, or whatever I'm telling. And wherever you have any problem, it's you can just interrupt and ask your query. So we'll start probably now. So is my screen visible to everyone? Okay. So at any time, if you guys have any query, just unmute yourself and ask. Meanwhile, can any one of you just unmute yourself and say something, so that I know that I am also able to listen, because till now none of you guys unmuted yourself.
Sir, am I audible?
If you are not able to unmute yourself, let me know.
Sir, am I audible?
Are you guys able to unmute yourself or not?
Yes, sir.
Sorry, I did not hear anything. I saw someone being unmuted. And just some of you can unmute yourself and just confirm.
Sir, am I audible?
Yeah. Okay. So I'll start now. In case you guys have any query at any point, just unmute yourself and ask. Okay.
Sir, can we do this course on a tab instead of computer or a laptop?
So you need this R software. So actually there is a, you can't install R in tablet. There is no version for tablet. However, there is another alternative that if you guys are familiar with Google Colab, so there you get an option to use R, but I can show that if you want. But it's good if you have PC or any laptop, because without it, it may be difficult. It is possible, but it's not very user friendly in tablet. So if you want, I can show that also how you can do that. But I would suggest you to work with tablet or laptop. Laptop or computer. Okay, so I'll just, so one thing I want to tell that I am using Mac OS. Okay, so some of you might be using Mac, others might be using Windows. So what I am showing, so code and all will work exactly what I am saying, but some GUI things might be different, like how things look into your system might differ if you are using Windows, because I am using Mac as of now. So those things you need to check. Okay, if you are facing any problem in Windows, let me know, I will try to help. Okay, so first of all I will just briefly cover what all has been covered in the entire 1 week. Okay, first week, and then we'll try to solve some questions. Okay, so this this whole course is built to help you understand different aspects of our software. Okay, and perform data analysis using our software. Okay, so here we'll just try to introduce first that what is actually our software, why it is required, and then gradually we will try to learn what all we can do with this software. Okay, and why particularly this software is helpful in comparison to others, many other softwares. Okay, so I will just introduce myself. My name is Adarsh Kumar Verma. I am a PhD scholar and a PMRA fellow at the Center for Psychology, School of Medical Sciences, University of Hyderabad. So every week we'll be having these sessions at 5 p.m. On Saturday. So it's good if you guys join, and if you have any query we can solve. Okay, so first of all, so this is the same thing that you might have already seen in the lectures, and I will suggest you to watch all the videos before attending this course, so because that will help you guys only. So first of all, what is R? So it is a software, but it has its own programming language. If you guys are familiar with another programming like Python or MATLAB or C++, anything, so they all run on programming. So they in all these places you need to type some code which will give you some output. Okay, and just like that, this R is also one more programming language, but this is specifically dedicated to statistical analysis. Okay, and unlike any other programming language, these are also case sensitive. For example, capital A is different than small a in R or in any programming language. So that's one thing that this R. So there is also a graphical user interface option, but people hardly use that, and it is I don't find it very helpful. So it's better to go with programming only, and over time you will learn how actually to use this programming language to solve your different statistical problems. Okay, so and why this is named as R? So earlier there was a software called S plus, and so this comes after S. So these people who that is Professor Ross Iaka and Robert Gentleman, these people mainly founded or started this R software, and based on their first letter it is named as R. So why mainly you should use this software? Because there are multiple softwares in the market. For example, some of you might be using SPSS, other might be using JASP. So there are many free softwares also, many paid softwares also, right? Like JASP is one free software and SPSS is paid software. Okay, but the problem with those softwares is that you don't know what is happening behind the hood. Okay, so in those software, what you do, so that's what it means, that this particular R, it is open source software. So in those softwares, what you do, you simply give your data to a software, and you ask software to give you output depending on whether you want correlation, regression, or what type of statistical analysis. It doesn't matter. Okay, so you just provide your data, you ask for output, you get output. Okay, but for example, let's say you are trying to predict rain based on different factors like humidity or temperature and many more things. Okay, and you just want to find out whether these variables are predicting the rain or not. So you just gave data, you selected some option, and you got the output. Okay, but you don't know actually what is actually that particular software is running. Okay, however, in R it is completely open source, means that whatever functions are there, you can exactly see what is happening, and we'll see, and I will show you what I actually mean by that. That when, for example, if you say mean in bracket whatever you put your data and you for calculating mean, or if you calculate SD. So for SD so there is one function called SD, okay, for calculating this standard deviation. But if you want to see how that SD function is working, you can simply see, look into its script. That's what I am telling, that it is open source. You can simply see what is happening, okay, while using any of the function, and you can change that as well. And in on these other existing softwares or other softwares, you cannot manipulate or you cannot change what a particular function is doing. That flexibility R gives to you, okay. Along with that, so another limitation of these so-called softwares, or these graphical user interface softwares, is that there you put data, you select some option, you run it, okay. For example, so I'll just give one example. So let's say you are teaching in some class, and you collected anxiety scores from different students, okay, during their examination, and you want to run some analysis. So for example, from class 10th you collected data and you want to analyze it, depending on whatever your requirements are. So what you will do, you will feed your data to the software, you will select your required option, you will run, you will get the output, okay. Now let's say your principal asked you to do the same job for all classes from class 1st to class 12th. So now in that case, what you have to do, you will simply run the same thing 12 times, right? Although some softwares do offer flexibility of using scripts, but majority of them don't, okay. So there you need to run this same protocol 12 times. However, when you are using R, it gives you flexibility of just changing the dataset name, and you can simply select all and run, and it will 12 times you can run just by changing one letter in your dataset name. That's it. So that's what you can do with R. You can once you can write a code for only one dataset. For example, for saying anxiety in class 10th, you can write a script for that, and you can simply keep changing class 10th scores to class 12th, class 11th, and so on. And you can simply keep running the same script again and again without changing much, okay. So that's one thing where R is very helpful, and this you will you will understand its how helpful it is when you are dealing with multiple data sets or large data sets. So there it is quite helpful. And another thing is flexibility, that you can change functions, you can run different things. So one thing is that, so for example, every now and then you see that there are some advancement coming in different statistical analysis. So, okay, for example, different new regression techniques or non-parametric techniques and so on. So these things keeps evolving, okay. And these existing softwares, what they do, they incorporate these changes over years, okay. For example, someone, let's say in 2026, published some article that this non-parametric form of ANOVA, if we tweak this parameter, it can give us better result, right? Now, these corporate softwares, they will not incorporate those things immediately, okay? They will take time, and even when they will incorporate those things, you will not know how that particular function is running in their software. However, in R, you can change that particular function, or you can adapt it as per your need immediately, okay. As soon as you see that article published, you can incorporate that in your results. So all such flexibility is there with R, which you will not get with many other softwares, okay. So that's the reason this R is widely used software all over the world, okay, for statistical analysis. So that was a bit background why we need R. Now I will just demonstrate how to download R. So for downloading R, you can go to R's website. So you can simply search R CRAN. You will end up with this user interface, and after that you can click on this CRAN, and it will show you different servers, okay, from where you can download this R software, and you can select any of these and you'll be able to install. After that, after you click on any of these servers, it will redirect you to another page where it will give you option to install R for any of the OS, okay. For example, so as one of you asked earlier, whether you can run on tablet. So that's what I was telling. It is not designed to run on tablets. You need either one of these operating systems. Okay, whether you are using Linux or Mac operating system or Windows. Okay. Now, for Mac users, till here everything is well and good. Okay, you don't need to do anything else for running basic R. But if you are a Windows user, you need to do one more step. I mean, if even if you're not installing this, so you will also get an option to install R tools. Okay, so in Mac, if you are installing R till here, well and good, everything will work. And for Windows users also, it will work. But when you will try to use external packages, we'll talk about it in some time. So when you try to install those packages, then you will see different errors popping up in your R. Okay, so that's why you need these R tools, which will help to compile those packages and so on. So for Windows user, this additional step is required. Okay, and once you successfully install everything, you will start seeing icon like this in your Windows or your Mac systems, which when you click, you will be able to open the R console window. Okay, which will look something like this. I will demonstrate also everything in my PC, don't worry. So this is how our console look like, where you will see different options. Okay, let me run it in my system. Okay, so I will just show how to actually run, so you don't need to go through those links. You can simply Google it. So like RCran, I can search and it will open this window. So here you can see it is giving me 3 options. I can download for Linux or Mac OS or Windows. Okay, for example, if I'm a Mac user, I can select this and I can download any of these depending on my requirement. For example, whatever operating system I'm using, accordingly, for example, I'm not using this operating system, so I can download this package based on which operating system I'm using. For example, I can simply click on this and it will start downloading a software for me. Okay, if you are a Windows user, you can select Windows. Now here, once you see that when you clicked on Windows, now unlike Mac OS, it is giving you different options. Okay, first it is asking you to download base software. The second and third, you don't need to worry about it. But here you are also getting this R tools option. So first you need to install this R, so you can click on it and it will download at any place. If it is asking you to select those servers, please select that and then come back and go to R tools and download any of these versions. I will suggest you to download 4.4 as of now, because that is a stable version. And usually newer versions are under testing, so there you may find some glitches and all, so it's better to install the stable versions. And once you download those things, you can simply install them. For example, if I come here, I can simply double click on it. Sorry. For example, if you're a Mac user, you can install it. So all these steps you have to follow. Since I already installed, I will not go through all these steps, so you can simply follow all the steps that you are seeing and keep hitting continue, and at the end it will install in your system. Okay, so as of now, can you guys tell if any one of you is facing problem in installing this R? If for any one of you it is not working or you are facing any issues. I hope none of you are having any problem with installation of R. Okay, so
Good evening, sir.
yeah,
Sir, R Studio means?
so R Studio is just a wrapper which you know where you use R. We will come to R Studio as well, but as of now, just are you able to install R properly? Is it working?
Okay, sir.
So we'll come to R Studio, don't worry, and we'll take a look into that also in detail. Don't worry about that.
Thanks.
Yeah. Okay. So So here you can simply open your R console. So if you simply run R, you will see something like this. These options may vary depending on which operating system you are using, because for example in my system it is showing these options. So this is our console, so it's more like a terminal in your Mac or command window in your Windows systems. So here you will get a place where you can write anything, okay, and you can run from there. So here once when you will open in the beginning, you will see something like this, okay, like which R version you installed, for example 4.5.2, and some basic details like how you can how you can start working with R, where you can get help, for example you can see these options. So these basic things you will get. So here, okay, we will come to data structures and all after some time, but just for the sake of helping you understand how it runs. So here you can write anything, for example like you do in your 10th or 12th class mathematics. So here you can save or enter any number or any set of numbers into any particular variable. For example, I can say a equals to 2, okay, and I can simply hit enter, and this a I will have in my environment. Now one problem with this R console is that you can't see all these variables, what all you have, okay. Once for example you write more and more script, like there will be thousands of lines in your R, so at one point you will start forgetting that what all previous variables are there, okay. For example, whether you saved any value in A or not, you may forget. So that's where R Studio comes into picture, which helps you visualize all those things. We'll come to it in a bit, but as of now ignore them. So here once I tell a equals to 2, it will save 2 into my variable a. Now if I simply type a and again hit enter, you will see that my value of a will be popping up, okay, which is 2. Now similarly I can write many other variables, for example b equals to 4, and I can do calculations like c equals to a plus b, okay. Now these things are running. It will not show you output unless you ask it explicitly. For example, now if I simply say C, now you will see the answer, which is 6. So 4 plus 2 equals to 6. Now here you might also be okay. So here you are also seeing this one number, okay. Now what this one is depicting, so this one is depicting the index of particular number. For example, so you can save more than one value in any variable. For example, I want to say a equals to 1, 2, 5, 10, whatever, okay. So now, okay, one more thing I want to show. So in R it is not common to use equals to, okay. Instead in R we use this symbol, okay, less than and hyphen, okay, to put any value in that variable. For example, if I want to put 10 into a variable named a, so that's what I am saying, that 10 is going into a, okay, that's what you are saying. So saving in a, so this is equivalent to equals to, but in R it is more common to use this symbol instead of equals to. So some people, you might see that some people are using equals to, some people are using this symbol, so don't worry about that, both are equal, okay. So I'll be using these symbols rather than equals to, okay. So now I can save like this. Now instead of just putting one number, how we can put more than one number, okay. For example, I want to put, let's say my anything like data, I want to save number 1 to 10. So if you want to save a set of numbers in a sequence, okay, for example 1, 2, 3, 4, all whole numbers like 1 to 10, okay. So in that case you can simply use colon and you can put 10 and you can enter, okay. Now if you again try to print your data, you will see it is printing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay. Now but this same thing will not work if you want to save data like 2, 5, 4, anything, okay. If it is not in a sequence, this approach will not work, okay. Instead what you need to do is that So here you need to put C. C means combine. Okay, here in R. So C means combine. So you put C, then you put one bracket, and then you can enter whatever numbers separated by commas. For example, 2, 4, 6, 8, or 2 again 8, and so on. Okay. Now if I run, you will again see that now it worked. Okay. You got it. I hope this till here it is clear for everyone. Okay, that when you want numbers in a sequence, you need to write like this. Here also you can write C, that's not a problem, but here you don't need to. But when you are trying to enter non-continuous numbers, for example, even if I want to enter 4 to 10, I can simply use 4 colon 10, that will work. But if I want to say 1 comma 4 to 10, that will not work. Okay, in that case you need to use this C function, and then you need to combine all those numbers. Now what this 1 is depicting is that this 1 is the index of this first value, which is 2. Okay, for example, here we saw that we used 2 as a first number, so that's what it is saying, that first number is 2. Now this number will come if when your these output values will move to next row. Okay, for example, okay, I will demonstrate you. So let's say data 3, let's say 200. Okay, now if I say data 3, now you will see what it is showing is that, so this first value, whatever it is printing in a particular row, for that index is 1. Next value, whichever it is printing in the second row, its index is 32. Okay, so that's what it is telling, that whatever is the first value in the next row, it is simply saying that that is the index of my 32 value. Okay, so don't confuse between these indexes and your actual values. These are your actual values, these are just indexing. Okay, where that particular value is located in your particular variable. Okay, now till here everything is well and good. You can do all sort of calculations, you can do mean and so on. For example, if I want to do mean, I want to calculate mean of, let's say, this data 3. Okay, I can simply say mean in bracket data 3, and I can hit enter, and I can see the outcome. Okay, 100.5. Okay, now till now whatever I have done, as soon as I close my R, all these things will be gone. Okay, if I want to do the same thing again, I need to write everything again. Okay, so here in R there is a flexibility that you can write all these, all these things, that whatever I wrote, I can write it in a separate script. Okay, so here you can simply go to new file, new document, or depending on what software, what version you are using, it may change slightly. But everywhere you will get an option to, for example, in some of your case it may show new script or something like that. So it will simply open a new script where you can write things and save it, because as at this point from our console you cannot save this thing. Okay, as soon as you close your R, it will go away. Okay, whatever you have wrote. Now what I can do, I can simply open a new document. Okay, here now it opened another window for me. Now what I can do, I can write the same thing here. For example, data 3, and just first let me show you what will happen once we close it. So as soon as I close my R console, and if I open my R again, you will see everything is clear. Now if earlier I mentioned data 3, as soon as I write anything, everything is gone. Okay, now here you need an R script, so that whatever you are writing, you can save it. Okay, so that you can run the same thing again. So what you can do, you can go to file, new document, or a new script, and instead of writing everything here, you can write things here. Don't worry about that, you don't need to do these things, because here I'm just showing you how things work. As soon as we'll move into R Studio, these things will become very easy for you. Okay, and from next lecture onwards, we'll be using R Studio only, not R console. Okay, so because everything is integrated in that software. Here I'm just showing you how things actually work. Okay, so now what I can do, I can simply say data 3 equals to, let's say 3 is to 300. Okay, now here as you see right now I entered things, I hit enter and I reached the next line. Okay, now I can say I want to calculate mean of this data 3. Okay, whatever data is there I have, I want to calculate mean of that data. Okay, now what I can do, currently nothing is running here. If I want to run something, I need to put cursor on this line and I can simply say hit control and enter. Okay, depending on which OS you are using. So for me it is command and enter. For Windows user it will be control plus enter. Okay, as soon as you run this line, hit control and enter here. Okay, like this, you will see that that line will run in your R console automatically. Okay, now if I go to second line and I again hit control enter, you will see it will again run my second line and it will print the output. Okay, now if I close, now I can save this R script, whatever I was writing this side, okay, in any file name. Okay, like demo.r. Okay, now I can close everything. Now instead what I can do, I can again open R and I can open my existing script. For example, I can open my existing document which I saved as demo.r. Now as soon as I opened that, you saw that my old script is already there. Now what I can do, I can simply select all and I can control enter. You can see now I don't need to write the same thing again and again. Once I wrote those things, I can simply do the analysis again and again. Okay, here I gave you very simple example, but when you do many things, like you want to do mean, ST, ANOVA, you want to plot things, you want to change things. So in that case, you probably end up with 1000 to 2000 or 5000 lines of code. Okay, so there it is very helpful when you write in such R scripts, which you can later reuse. Okay, so this is what R console looks like, and R script is simple one more document where you can type things and you can save it in your hard disk. Okay, so that's what I mentioned. Now since you guys are new to R, so first thing is that you need to learn how to get help whenever you want to do something. Okay, now one thing is that in your R console, one second. Okay, so one thing is that you can simply go to help section and you can click on R help. Okay, now it will open a window like this where it will have a proper manual where most of the basic things which you want to do, you will find proper documentation of all those things. For example, an introduction to R, here I can see all sort of things which I need. Okay, like information about R environment if I want to do something. Okay, for example, for matrix related things. So all these things, so these are the codes and this is the information about that particular thing. Okay, so wherever you are seeing this function, this is not less than or greater than symbol in R. So for example, this in whether you are using R or R Studio, everywhere in that console you will see this symbol. So this is not equals to or greater than less than or greater than. This is simply saying that here you need to enter. So this is depicting the new line where you will be entering the code. Okay, so when you are seeing these documentation, irrespective of whether you are checking R's documentation or you are looking into some Google web, some other website, everywhere you will see that people will be showing you these commands using this entire line. So here you only need to enter these things, not this first part. Okay, because first part is already there. Okay, it is just depicting new line. What you have to actually enter or try running is these codes. Okay, So like this you can look for its documentation and you can see how things work. Okay, so this is one thing, but usually no one uses this documentation, okay, to be frank. And the same thing you can open with help.start as well. So if I simply type help.start, so you will see that it will again open the same window. Okay, so either you can go through the options or you can type code, it will end up in the same documentation. Okay. Next is, so this is quite helpful and this you will need very often. Okay, because you know how, what is the function. For example, for mean it is simply mean. Okay, if I wanted to calculate mean, I mentioned mean. Okay, but I don't know how I need to input my data. Okay, so now what I can do, I can simply say question mark and mean, and if I hit enter, you will see another window popping up. So again, how these things appear will change in RStudio. This I am just showing for the sake of understanding this R console part. Okay, so now if you want to get any help for mean, like how you can use this function mean, for example, you are new, you don't know how R works, you know how different functions work, so those things you need to learn in the beginning. And you know it's not a rote learning that will work in this case. Once you use things again and again in statistical softwares or any programming language, that's how you learn. Okay, so in the beginning you can simply type question mark, you know that function is mean, but how to use you don't know. So now you will see that it will pop up the entire description of that function. It will tell what this function is designed to do and how to use that function. Now here you are seeing two things. Okay, one, it is saying that mean in bracket you can put x, where you can see what is x. X is some data, okay, or numerical or logical vector or anything. Okay, now apart from that you can see many more options. So usually in most of the cases you don't need later options. Those things you need when you want to tweak certain parameters. Okay, I will come to it later when required, but as of now this is the main thing, that first value needs to be your data. Okay, for example, we saved our data here, this 3 to 3000 into a variable named data3. So that's my data. Okay, as I showed you earlier also. Now first thing you need to enter in your function is that data set. Okay, either I can mention 3 to 3000, okay, or 1 is let's take that example only. Okay, either I can directly enter this data here, or I can first save that data into some variable and then I can use that variable here. Okay, both will work and both will give you same output. The main thing is that how you need to enter that data, that you should learn. Okay, so in that case I need to provide the entire vector of data. For example, instead of putting this one sequence, I want to calculate this mean for another data set like 2, 4. So as I mentioned earlier, you need to put C for if you are not using a continuous numbers. So like 2, 4 again and again. So these things you can use inside these functions also. Okay, so now I can run this. Now if I try to print my data1, so you can simply select this or highlight this thing and control enter and it will simply print all the values. So as you see, I put 2, 4, 2, 4, 5. So you can see 2, 4, 2, 4, 5. Then I put 2 to 10. So after 5 you can see 2, 3, 4, 5, 6, 7, 8, 9, 10, and after that I saved 2. So you can see how things are working here. Okay, once I did that, as I mentioned, I just need to change my this dataset name, that now instead of perform mean for data3, I want to perform mean for data1. Okay, now again if I enter, you can see my new mean. Okay, so that's the thing. So now another thing is that, so right now I used a function called mean. Okay, so you know that if you want to calculate mean, you will write mean, it will work. Now I want to calculate standard deviation of the same data, but I don't know what is the function as I am new to it. Okay, now what can I do? Okay, so for that there is another function called help.search. Okay, so instead what you can do, you can say help.search, and in bracket you can mention standard deviation. Okay, you don't know what is the exact function as of now for a standard deviation, but you want to use it somehow. So because this standard deviation will be appearing in the description of whatever function is there for calculating ST. Okay, so what I can do, I can simply say standard deviation and I can hit enter. Now you will see it is opening another window for me. Now it is showing all the functions where that standard deviation word is appearing. Okay, now these are different functions which are coming from different packages. Okay, we'll come to packages again, but as of now this is the main thing that you want for calculating standard deviation. So you can see this SD is the function, so stats is the package, and you are seeing 2 times colon then SD. So stats is the package and SD is the function. So instead of standard deviation you need to use SD for calculating standard deviation for any data set. Now if you click here, it will again open the same documentation that it will show when you put question mark SD. Okay, so now what we can do, so now we know that SD is the function that we need to use, right? Now what I can do, I can simply say SD. Now since we know SD but we don't know how to use this function, so I can simply say question mark SD, so it will open the same documentation. So again, as you can see it is saying that after the function I need to provide my data set. So X is showing as a numeric vector of an R object. Okay, we'll talk about different types of data vector, array, list, table, all those things we'll talk in future sessions. Don't worry about those things, but as of now just see how things are working out. Okay, so now you know how SD function needs to be used. So primarily you need to put the data inside the function SD. These na.rm, these are not required, so it is simply saying that if any value in my data is na or not applicable, simply remove that value and calculate my SD while excluding that particular value. By default it is already there, so you don't need to enter anything. You can simply say SD and you can enter your data. Okay, now what I can do, I can simply say SD, in bracket I can put my data 1, and I can again hit control enter, and you will see it run my this thing and it saved the data as well. Okay, sorry, it gives the output as well. So standard deviation for this data is 2.642149. Okay, now as you can see I am writing all these scripts right now. Okay, but after some time I may forget why I wrote that particular line, right? Now what I can do, in these scripts we can use comment thing. So we can comment different parts. Commenting means that particular thing whatever we will write will not work. Okay, so what we can say is that so for that we need to use this symbol hashtag. Okay, so everything I will write after this particular symbol, that will not run in that line. Okay, so here what I can say, that I can simply write comment for my feasibility, that combining non-continuous numbers. Okay, so now if I simply hit control enter again while putting my cursor on this line, you will see it will run, but it will not give any error. But if that hashtag is not there and if I try to run this thing, you will see that it is showing some error, that this combining and non, these are neither any symbols nor any functions in this data set or in this R session, anything. So that's what it will not work. So if you want to put some comment for your later understanding, for example, if you are later seeing this same code to understand that how I need to combine unconditional number, you can simply open your old script, and after reading this comment you can see that this is how you can combine your non-continuous numbers. Okay, Now similarly here I can put again mean, and that line will run, but it will not give any error because it is not actually running, it is simply printing that line, nothing more than that. Okay, if I want to calculate mean, I can write like this. And if I again, if I want to look for how to search for st function, so again if I run this, you will see it will not do anything, but if when I will run the next line, it will open the same pop-up. Now one more thing is that you don't always need to enter these comments, or if you want, you don't need to always enter these comments in the separate line. You can simply, whatever function is there, you can, whatever you want to run in your R, you can write that and follow. After that you can put hashtag, and anything you will write after that, that thing will not run. So what will happen is that R will run this thing, but not anything that is coming after this. Okay, that's what it does. So okay, so now if I run this, you see that it run this part, and because of that it opened this pop-up, but it did not give any error for this because that is a comment which R is not running. Okay, it is simply printing it out. Okay, and now you can save this demo and you can reopen this later on for your understanding. Okay, so that's how you can look for any function if you want to do anything. Now next thing is that, okay, so sometimes, okay, sometimes you will see that same function, for example here you are seeing hd, okay, or let's say ANOVA. Okay, so sometimes there are different packages which have same function. Okay, like ANOVA, let's say stats package is also having ANOVA, and psych package is also using ANOVA, has a function called ANOVA. Now there are multiple packages which have the same function. Okay, so in that case you can see that what all packages have that particular function. Okay, because let's say because these different packages might be implementing or doing ANOVA in a slightly different fashion, ways. Okay, and they may also produce slightly different results. Okay, so now how to see that, is there only one package which has a particular function, or there are more than one packages? Okay, so in that case you can simply use this function called find, and you can put that. So for example, I can find which all functions uses hd, or let's say take another example. Okay, now if I run this, so here you can see that there is only one package called stats which have this function ANOVA. Okay, so now you are confident that whatever you are trying to run is coming just from this one package, from which you actually want to run. Okay, but it may not be always the case. So in some cases there may be more than one package. So in that case, how to use that particular function? So for example, okay, I will again take an example of mean. Okay, so let's say how many packages are there which have a package called this thing called mean. Okay, function called mean. So let's say stat package, it is not there, but just assume that there is a stats package also which has a function called mean, and there is a base package also which has a function called mean. Okay, but I want to run this mean function from my base package. So in that case, what I can do, I can simply say base, and then like this I can type mean, and then I can continue with my previous how I was entering my data. So now what it will do, it will simply run this particular function from that exact package whatever we are mentioning. For example, base package, it will run mean, not from the stats package. So that's one thing, because you know, when you are dealing with higher level of statistics, because as soon as you move to ANOVA or using functions called AOV and LM and so on, there you will see that many different packages have the same variable or same functions, and one thing may not work for, I mean, same type of data inputs or same type of outputs you may not get with all functions. Okay, from all packages. So that's where you need this thing, that you see that what all packages have this function and what particular which function you want to use from which package. So that's one helpful thing, that that's where you need to use this find. Next thing, there is another thing called this another function apropos. Now here, let's say I know I want to do something. Okay, for example, I want to do ANOVA, some non-parametric ANOVA, but I know some part of it but not all. So for example, in ANOVA I know that there is a function called AOV, but there may be some other function also which has more than AOV, for example LM AOV, something like that. Okay, for example, is there any other function which also has LM in its function? Okay, so in that case I can use these functions. So like APR and in bracket you can write, for example, LM. So now it will show all the functions which are available where this LM is there. Okay, for example, here you see in call means there is LM, there is lm.fit, there is LM. So it is simply printing all the variables where LM keyword is there, okay, or LM is coming in particular function. So it will print all those things and you can simply search which all you need. For example, let's say there is a particular non-parametric ANOVA. For example, it is called art ANOVA. Okay, now I don't know how to actually run it or what is the exact function for that art, but I know that somewhere there is ART, but is it just ART or ART ANOVA, complete that thing, or how to run, I don't know what is the exact function. I just know that there is art in that particular function. So what I can do, I can simply type ART. Now you are seeing that it is listing out all the functions which has ART. For example, here there is ART. In all functions you will find ART is there, but what function I want is not here. Okay, now here you see that, okay, once, okay, I will come to it. Okay, so it will show only those functions, whatever packages are there in your current environment. Okay, I will come to how to install external packages and all, but this art ANOVA, as what I'm mentioning, so this particular function is coming from an external package which ANOVA does not have by art does not have by default in its base package. We need to install it from outside. I will show you how to install, but as of now I am telling, so there is a package called R tools. Okay, so ART, and as I mentioned, these are case sensitive. I am just typing it because I already know what is this package. We'll come to it how to load and all. As of now, just ignore that. So I'm just loading one package which actually have this function. Okay, so unless you load that particular function, you will not see that function. Okay, even if you search for this particular function, it will not come up unless you load that library. Now once I loaded this library, now if I run this function again, now if I go up, you will see a new function is popping up which is ART. So that's the actual function which I need to use. Okay, now again, how to use that particular function, I can simply type question mark and ART, and again it will open the entire description of how to use that particular function. Okay, so we'll come to those things later on. So that's one thing you need to understand, that if you are searching for any particular function or part of it, it may not always show up using that function unless you load that particular library in your current environment. Okay, so that's one thing, and you don't actually need to learn all these functions. It's good to learn, but it's not a problem. You can simply Google it and use it. Okay, another thing is that, so here when you open any documentation, okay, for example here if you see, now at the bottom if you scroll down, you will see all type of things. So first is the description, then how to use that particular function, and then what all these inputs mean. So all these argument details are there, and at the end most of the times it gives some examples. Okay, for example, these are the example for using these functions, okay, for art function and so on. Now most of these packages have example data sets, okay, or example codes. So one thing, I mean, people rarely use that, but you can use that using simply say example, and you can put that function. For example, I can simply say example, and let's say for LM I want to search, or I want to see how people use this particular function. Okay, so now if I simply hit control enter, you will see here it run the whole command. Okay, all the commands which probably are already here. Okay, so what it will try to do, or most of the times it may also be different. So here it will simply showing you how to use that particular function. Okay, it will generate all sorts of commands which are required to run particular function. For example, first of all, it is putting a particular data into a variable, okay, and then another variable, and then using, I mean, putting all those variables into a table or combining them into a table, and then using the function to predict different things. So we'll come to think, don't worry about these things, how to use that thing. We'll get into it in detail, so don't get frustrated by seeing these things. But the main purpose here is that you can find examples or example codes of how to run a particular function, okay, simply by typing example and in bracket putting that function. Okay, next, this demo function is mainly it is mainly for those packages which are graphical in nature, and you will not find demo for all the packages, but for some you will find, for example, if you want to do check a demo for, like, for example, how to use this graphics package. Okay, so now it will open. Let me close and run again. So now it will just type a command, for example here pi in bracket all my commands, and once you run you will see this particular plot. So it is simply showing demo that if you are running this command, this is how you will see a graphics. Okay, simply if I run again, so now if I run this particular command, it will result in this type of plot. So these are the demos of some of the packages. Okay, and you keep hitting entering, and it will keep generating the plots unless all its demos are over. Okay, and you will not find this demo function for all the packages. It is only for some selected packages. Now one more thing is that sometimes you know the package but you don't know the function. Okay, for example, you know that you need to use some function from stats package, okay, or this art package or art tool package, because stats package has, so this package has more than 100 or 200 functions, so I will not use that. So let's use this example code for another package. For example, let's use this tool. Okay, this package. Now if I, one second. Okay, so let's say I know that I want to use this package called R2. So this will work definitely only after loading this particular package. Okay, but if I want to use this package but I don't know how to use it, I mean, what all functions are exist. For example, earlier I mentioned that there is some function called ART, okay, or at least it has ART in its name, but I don't exactly know that whether there is ART or not. I just know that there is a package R2s which I can use for my particular objective. Okay, So for that I can simply run this command and I can see that what all functions are there, and I can see whether they are relevant for me again by using question mark and these particular functions. Okay, so that's one thing. So I will save this script whatever I'm typing right now in case you later need it. Okay, so here again I can put comment like check for inward functions. Okay, so now as I mentioned earlier, when we searched this thing, this art in our base R, it was not working. Okay, as you saw earlier, we had to install this we had to load this package R tools. Okay, it means that it was not there in my R by default. Okay, I had to install it from somewhere. Okay, now let's come to first to this slide. Okay, why we need separate packages. Okay, see, this R is developed by one set of people. Okay, but there are people all over the world who are using this R software. Okay, and they all are interested in different analysis. Okay, for example, me from psychology background, I might be using some psychology related packages. So one is called PSYCH. Someone from economics may be using different packages. Someone from biology might be using different package. Someone from environmental sciences might be using different packages. Okay, depending on their domain and so on. So all these people, what they do is that some of them develop their own individual packages. Okay, so that's where our flexibility comes into picture, where you can design your own functions, you can compile them, and you can make it available for other users as well. Okay, and that's how these packages come into existence, that across world many people develop different statistical techniques depending on their domain and in general also and they make these things publicly available. Okay, now if if base R package comes with all these different packages, which let's say thousands or lakhs of packages. Okay, if this R starts giving all these packages to you as a user, it will probably move beyond GBs and TVs. Okay, so your basic R package will become very huge. Okay, and your system might not be able to hold it. Okay, so that's what I mentioned, that it will become too big if you get all these things, and most of the things are not even relevant for you. Being from biology background, you might be just interested in something like biostatistics related packages and so on. You have nothing to do with physics related packages and so on. So why to put that into your system? It will just increase the size, you will never use them. Okay, so it's better to just fetch those packages which are required for you. Okay, so that's why you need there are these external packages or separate packages which you can install depending on your need. Okay, and once you install them, it stays in your system unless you voluntarily remove those packages. Okay, so it is just one time thing, you can simply install them. Okay, now we will come back to this slide, like how to install these packages. Okay, so now for example, there is a package for bootstrapping which does not come in by our base package. Okay, so for that there is a command install.packages. Okay, for example, I will type here, I will share this script with you guys later on. .packages. Okay, now one thing you notice here, that even if you are installing one package or more than one package, you need to always use S. It is always packages. So this is how R is designed. Okay, this you can't change. So you need to always mention install.packages. Then in bracket you can inside inverted commas you can type what function or what package you want to install. For example, boot package I want to install. I can simply run it and I can simply control enter and I can select a mirror from where or server from where I want to install. I can select anyone, so that doesn't matter. I can simply select particular that thing and it will install it in my system. Okay, it is just taking time. So you will see the updates, and at the end it will install that particular package. And if you want to install more package, you need to repeat this thing. Okay. Now, as I mentioned earlier, if you want to put more than one things under any function, you can use this function called C. It works for numbers, it works for strings, it works for packages, it works for everything. Okay, so let's say I want to install more than one package, so I can simply put C and I can add another bracket. Okay, and here I can put comma and I can put another package. For example, let's say again it is already installed in my system, but let's try again. Okay, so I can put more than one packages at the same time, and I can hit enter, and it will install all the packages required. Okay, so you can install more than one packages in one go. Okay. Now once you install these packages, now you need to use it. Okay, it's more like calling that particular package so that you can use them. Okay, now how you can use a particular package is that you can use a function called library, and you can call this function. For example, I want to use R2s, as I mentioned here. You need to type that, and after that you can use it. Right after installing, you cannot use unless you call that thing into your current. For example, I am running this. Okay, I want to run one command with R2s. I want to command or I want to more than one functions I want to run with particular package. So I don't need to write this library to this thing again and again. I need to just write it once and that's it. But as soon as you are closing your R console, when you are opening your R console next time and you want to use this particular library again, then again you need to run this particular line. Okay, this you don't need to run again and again. Once you did that, these particular packages are on your local system. Okay, it will not go. The only thing is that it will not be in your current environment, so you have to run the later part again and again. So this I am commenting as of now. So if you want to run this part, you can simply select this and hit Control Enter or Command Enter, and you will be able to run that. If I put this thing now, if I simply hit again Control Enter, you will see it will run, but it is treating it as a comment, not as a command. Okay, so this part you have to run again and again. So that's what I mentioned. If you want to install more than one package, you can use C for combining all those package names, as long as you know what all packages you require. Okay, and what all packages you require for a particular function, you can simply Google it. There is too much of information available online. Okay, and once you want to use that particular package, you need to use library function. And if you want to, so these packages are being developed and updated over time. Okay, for example, if there is some new feature or new function, the authors of that particular function keep updating their particular packages. So if you want to update your package, you can use update.packages, and in bracket again you can put up that particular function or package name, and it will update it. And if you don't want to update, there is no problem, all your existing things will work as it is. Okay, another thing is that once you know that you install a particular package, but you don't know what it is about or how to use it, so in that case you can type package description and it will open a description of that package. And so this will just show you who made that package, what are some basic details about that package, what it is for, and so on. But it will not tell you what all functions are there to run. So now instead of package description, you can use another function in bracket library. You can say help equals to that particular function package name. That will have this entire detail which you will be having under package description. Along with that, you will also see all the functions and many more details. Okay, so let's see the this later part. Okay, so what I can see is that library. So in this case, it will not load that library, it will simply open the documentation of that particular package. Okay, so help equals to now if I run this, now you will see it is opening another pop-up, and now if I see it is having complete description. Okay, till here, and after that it is also showing me all the functions which I can use for my that particular analysis. Okay, from here. But if if you are just using this package description part, it will only show above part, probably not these things. Okay, so if you really want to see the entire documentation of a particular package, it's better to go with this second function. Okay, now this people rarely use. I never use it in my practice, but I'm just telling it for the sake of your knowledge, that if so, for example, here you wanted to use our tool package, you install that, you loaded that package using library function. Now you don't want to use, you want to remove, you can remove it from your current environment. Okay, for that you can run this function called detach, and in bracket package colon your package name and unload equals to true. I will not type this thing, and you rarely require this thing. So, but this is the function if you want to remove a particular package from your current environment, not from your system. So it will simply remove it from your current session. Okay, if you want to use the same package again, you need to again load using that package using library function. After that, let's say you no longer want a particular package in your entire hard disk. Okay, not on your computer. Let's say it is occupying too much of space. For example, let's say you installed some package just to try it out, but then you found that it is very big package. Let's say it is taking 2 to 5 GB and so on. Okay, so you simply want to remove that thing from your system because you don't really require that package. So in that case you can use remove.packages. Okay, just like install.packages, it is remove.packages, and in bracket again you put that package name, and it will simply remove it from your entire system. Next time you want to use that package, you need to again go through this install.package first, then library, then use it. Okay, so this is how it looks like. Same thing I also showed you here. It will simply print all the progress of those packages, and once you want to use that, you need to use library function. Now till here, anyone has any question? You can simply unmute yourself if something is not clear, something is not working. Feel free to ask. Anyone, any query? You can type in your type in this thing. No query? Okay, so this R commander, so I showed you that screenshot as I showed you. So this is actually for R commander only, this RCMDR package. So it is simply a graphical user interface or GUI for R. So instead of writing the entire command, it gives you some functionality where you can simply, just like other softwares, you can load data by selecting some options, run some analysis by selecting those things. So this is simply a graphical user interface for R software. That's what this package gives you, but I never use that. So that's what this R commander package does. So it's simply one more wrapper on top of it, on top of R, if you really don't want to use a script, or if you don't want to type anything. That's where this R commander can help to some extent. But as soon as you want more detailed analysis, or you want to dig into a particular function, again you need to come to the R script. Okay. And okay, one more thing I will show you is that, as I mentioned earlier, this is not a black box, everything is open here. So as I mentioned here that let's say for ht this is a function. Okay, so you don't just need to use this function. If you really want to see that what is happening behind this ht function, you simply say ht and put your data. What all it did you don't know as of now, but if you really want to see what all is there in this particular function, so what is it is actually running, you can simply say edit and you can put that function name. Okay, now if I run this, you will see it is opening another pop-up. So what this pop-up is really doing is that every time you run hd, it is running this entire function. Okay, and your data or data1 is going in the space of x, and it is running this entire thing. So every time you are running, so this hd I showed you a very simple example. Now if I say, as I mentioned earlier, there is this function. Okay, you see this is a complicated function, there are too many things. So don't worry about all these brackets, or if it looks complicated at this point, everything will become easy as we move further. Okay, so don't worry about that. So main purpose here is that to show you that everything that R is doing, okay, behind those functions, everything you can see in detail what actually is happening, and if you want to change something you can change. But it's better not to interfere with these functions. If you really want to change this function, you can create your own new function where you modify these things and you can use those functions. Okay, so it's better practice not to change these existing functions. So it is better to see what is actually happening underneath your data. Okay, before you get the output, what actually happens. So all those things you can see using this function. Okay, so I can put comment. I will save this script so that you will later remember. Okay. So okay, so coming to books, there is no one book, or let me see. So what was your question? See, for introductory part you can use any book, but as you move further you will see, I mean, there is one book which is actually not listed here, so which is called Introduction to R by Andy Field. Okay, and it is not freely available, but if you just look here and there, you will get a soft copy of it. So I never read these things. Okay, I never read these books, so about these I actually don't know, but you can try any of these. So, and you will get many tutorials in Google, also in YouTube also, for everything. Okay, so because this is very widely used software. Okay, this is not just used by a handful of people, there are many users for this, and you will see all sort of tutorials for anything that you want to do in R. Okay, so, and one book that I was suggesting is that, if sorry, this book, so this is quite good book, because these people, this person explains everything in great detail with engaging examples. It will not be it will not be boring for you when you read his book. Okay, you will find examples with which you can relate, and it has very detailed information about how to use particular function, how to work, and it starts from beginner. It is for everyone, whether you are a beginner or you are an advanced user of R. So it has details about for all type of people. Okay, and you will find it engaging. You can definitely use the mentioned books, whatever have been mentioned here, but along with that you can also try this book out if you are interested, and there is actually good stuff in that book. So okay, now coming to R Studio. Now till now whatever I talked about, so that was more to help you understand how things work in R. Okay, because now what we are about to download or about to see is just one wrapper which runs the same thing, same R console thing. Okay, basic R programming. So for that you can simply search for R Studio, or you can go to this website posit.co/download. So if I simply Google it, for example, R Studio, okay, and you can go to this download R Studio, and here once you click on download R Studio, you will, and once you come down, you will see different options. Okay, this website keeps changing over time. Okay, so don't worry about that. You will always find it. So if you are a Windows user, you can simply download this exe file. You can simply keep running it, keep clicking OK or whatever, and it will install R Studio for you. And for Mac users, you can select this DMG file. If you are a Ubuntu user, you can download these packages and install it properly. Okay, once you download this, you will get something like this. So once I clear everything, okay, let me reopen again. So now see, now this is R Studio, not R. So earlier, as you saw here, so here I was demonstrating everything in R console, right? So everything which was running here, R console. So this thing is here. Okay, this is that exact same window. Okay, same R window. Okay, R console. Along with that, you will be seeing two more windows. One is environment, another is this viewer. Okay, here there are multiple things, and one more thing that I showed you is that you can open a new script, you can type things, and you can save it. Okay, so this window also you can get here. So here it is just shown slightly differently. For example, if you click on this plus icon, here you will see different options. There are a hell lot of options in R Studio, and it's good to know all, but it's not required actually. Once you want to use more and more things, you can go ahead with those things, but basic things are same as earlier. So most basic thing that you need here is that R script. So once you click here, it is exactly same thing which you are seeing here. Okay, it is similarly, you can, whatever you are typing here, you can type here and save things. Okay, so for example, if I show you same thing, okay, I simply copied that and I try to run the same thing here. Okay, now whatever I'll be running here, okay, I will hit Control Enter, or I can click on this one option. I can simply say run, and you see that this particular thing will come up here and it will run. And as I mentioned here earlier, when I was running data 3 and so on, let's say I reached thousands of lines. Okay, now I don't know what all lines I already run or what all variables I already have. But now if you see that as soon as I run this data 3, R console run that line. Okay, now you see it is appearing here also, data 3. Now whatever variables you will be saving, these things will start coming up here. Okay, this is the environment I was talking about. Everything you run, for example data 1, you see data 1 also came up here, but it will not, nothing will come here. Okay, if I run mean thing, so here only those things will end up, or the values which are saving in some variable. For example, right now I just calculated mean of this thing, and if I want to save it, let's say a variable called a. Now as soon as I put this value in a variable a, then it will start appearing here. Okay, for example here, now you can see it run a and its value is 4.866 whatever, and as since we save a particular value in particular variable, it end up here in the environment. Okay, so now just to show you, so although I was supposed to tell these things in the next lecture, I am just telling as of now. So here you are seeing different windows. So this, as I've already mentioned, this is the same script which you can open n number of scripts. So you can keep opening, you can save it anywhere on your hard disk, you can reopen. Okay, and you can browse through, you can do all sort of things. And this is a console terminal. This is more like your base terminal of your entire operating system. For example, in Windows you may see another terminal which is actually your Windows terminal. Here it is, this terminal is for my Mac OS. Okay, these background jobs you see when you are running some things and it is running for long, then it will start appearing here in background jobs, so don't worry about those things. Now here you see environment. Environment means that whatever I'm running right now, what all things have been saved. Okay, for example, some value has been saved in a, something has been saved in data 1, data 3, so that's all things will end up in environment. Okay, history will show all the commands that I run till now. Okay, and most recent one at the bottom. Okay, for example, this is the last command that I run, which is at the bottommost, then this, and earlier I ran those many commands, so everything is there. Okay, so all history will come here, and these things are for networks and all, so don't worry about those things. Another major window is this part. Okay, which you can see here as files, plots, packages, help, viewer, and presentation. Now here most important things are these files. So now files, so this part is showing your, where everything is running at this point. For example, if let's say I am saving, let's say I am generating a plot. Okay, for example, if I simply say plot data, okay, so it generated this plot. Okay, so that's what appears in this plot window. Now if I save this plot simply using any function, whichever is appropriate function, in whether SVG file, PNG or JPG, as soon as I save this, it will go into this directory. Okay, as long as I change this directory. So this shows your default working space. Okay, and so whatever you plot comes in the plot section. Packages shows all the available packages for R. Okay, and what all things we can install, or you can simply search here different packages and you can install those packages. Help function, for example, if I write this $SD and if I run this, now you will see that instead of popping up new window, so earlier it was popping up this new window where you are seeing everything. Now it will not do that. Instead it will open this tab, which is help tab, and it will print the same information here. Okay, how you can use this information. Viewer also plot, generate separate different types of plots or figures or interactive figures and so on will come up. Viewer and presentation is not really helpful at this point. So this is how our studio works. So here every time you open something, new window comes up. Here in our studio everything is organized. You can simply keep typing, everything will keep going in appropriate places. Everything you want to run again and again, you can enter in a new script, you can save it for later use. Everything will run in R console by default. Okay, R Studio is not running anything. It is simply one wrapper of R console. Okay, and everything will run in R console only. Okay, but it helps you in seeing all the variables that you may have. Okay, it helps you in visualizing those variables, it helps you in visualizing plots, and it is user friendly. Okay, that's why in now onwards we'll be using R Studio rather than R. Okay, and I can save the scripts and I can share with you. Okay, so as of now I will share these this demo.r script, which you can later use if you want to see more. So that's what R Studio is. In the background everything is running on basic R console only. So earlier this R Studio page was like this, now they change, as I showed you recently. Now I have some sample questions which will help you solve your assignment. Okay, although assignment was very easy, I just have some questions. Okay, now first question is before that, do you guys have any further questions? Any questions you guys have? Feel free to ask before we move to some example questions. See, in the beginning it may feel quite complicated, this programming languages and all, specifically for those people who never used any programming language, but don't worry, over the time everything will start making sense and it will not be novel at the end of the course, and you will not fear as soon as you see any other programming language as well. Okay, so just watch lectures, attend the live sessions, you will understand things. Okay, so R commander I never used, so I don't really know, but you can simply Google it, you will find ways, because I always use R script and that is actually more helpful than using R commander. And I suggest you also to try to use scripts as much as possible. Okay, those lines, because as I mentioned, with R commander you'll face same problem that you face with other softwares, that you can't save your script. Every time you want to run the same thing, every time you have to open that pop-up and select things, and you have to follow the whole protocol again and again. In normal, if you're writing normal R script, that problem will not come. You can simply, for example, what I can do, I can simply select all, Control A, and I can hit Control Enter. Everything will run all of a sudden. Okay, it is showing error because I run art command before loading that package. Okay, this part, that's why it is not in the current environment, so that's why it is showing that error. So you can simply select all and run. That is much more helpful than using R commander. Any other question? I am not discouraging using that function, but I never used, so you can look into it. Any other question? Okay, let's move to questions. Okay, so first question is, which command installs package dplyr? So you can type answer. Okay, as I mentioned, when you are installing any package or removing any package, it is not package, it is always packages. And one more thing is that when you are dealing with these packages, sometimes you will be seeing that some people are using these double quotes, some people are not using. Both works when you are dealing with packages. Okay, so don't worry about that. If you are using quotes, well and good. If you are not using, that is also fine. But the main problem is that or it's a good practice that you should be consistent in your usage. That will help you, as you will see later, that when you are using double quotes, particularly not in the package, but when you are dealing with your data, sometimes you will have string data. Okay, that is some not numerical data, but some alphabets or something. For example, you have a variable called names with others, or and many other names. So in that case, sometimes you, if you use double quotes, it will work. If you use single quotes, it work. But the problem is that if you want to combine double quotes variable with single quotes variable, it will not work. So it is always a better practice to follow one particular rule. You can either use single quotes or double quotes, but be consistent in your usage. Okay. So when you're dealing with any packages, particularly you need to provide packages, not just as whether it is one package or more than one package. So it's install.packages as it's a correct answer. Next, which command loads the package mass? Although these are quite easy questions. Yes, again it is library in bracket mass. Here if I put this mass in double quotes, it will work. Next, which command displays the documentation for function st? See my question, it is which command displays the documentation for the function st. So it is C. So as I mentioned earlier, also there was a function called package something. I forgot that function. There was one large function that will also show documentation, but it will not tell you what all functions can be used. Okay, although I did not include that option here. So here when you use library help equals to st, then it will have all the details about st, including the functions and many more details. Okay. Next, which command is equivalent to help mean? Okay, I did not talk about this function, but I think in one of the lectures that professor told about this function. So which command is equivalent to help mean? Yes, it is question mark A. Next, which command searches all installed help files for a word regression? So let's say you don't know which function is required to run regression, but you know that I am doing regression. So how you can fetch all the functions which are responsible for running regression? I think it is help.search regression. So it's B option. If you simply search help.search in bracket regression, for example, I can show you help.search. So you see, so all help will appear in this tab only, okay, in RStudio. So you see, for running regression, these are the functions, for example, categorical, interaction, plot, effect plot, sum, and so on. And these are the packages, interactions, JTool, and these things. So this is the correct answer for this. That if you just want to know what you want to run, but you don't know the exact function, that's the place where you need this help.search function. Okay. Because see the question that I am asking, that which command searches all things which can run regression. Okay. Next, which command opens the HTML help page, like basic page with all help, all our documentations? You can type in your chat answer for this question. Yes, it's help.start. It will open that one whole page. Next, which command lists the content of the package mass? Like everything, all the functions, data sets, information about that package. Yes, it's A, because this package description will only list the description of that package, not the involved functions or other things. So if you type this first thing, library help equals to mass, that will actually give you entire documentation of the mass package. Next, which command displays all currently attached packages? Packages, install.packages, search, library. I did not talk in my PPT, but if it appeared in the lectures, can you guys guess? No. So if you want to see that, okay, 1 second. Yeah, I think here it is. So it is actually install.packages. So just like, so for installing it is install.packages. For install, all the packages that you already installed will come under installed.packages. Okay. So it's option B. Now, which command runs a demonstration called graphics? I need more answers for this question. Which command runs a demonstration called graphics? So for this, both A and B are correct actually. So as I mentioned, when you are dealing with packages, okay, if you're not putting quotes, that will also work. If you're putting quotes, that will also work. Okay. So here both A and B are correct. Okay. Next, which command permanently removes the package ggplot from your entire system? First, second, third, or fourth? Yes, it's remove dot packages, so it will remove that particular package from your entire system. If you want to use it again, you need to install it again. Okay. So that's it as of now. If you have any question, you can ask right now. If later while watching videos or lectures, if you face any question, so there is this discussion forum where you feel free to post your queries. For example, you can go to your once you go to your course, you will see that option of question and answer, and it will redirect you to a forum. Okay. So you can open this. So if you have any query, you can simply post your questions here. Okay. And someone from the entire team will answer your queries. Okay. Any question you guys have right now before we end the meeting? Anything? So anything you want in upcoming lectures, like some more details or more detailed explanations or something, you can give feedback as well. should we end the session? Okay, thank you everyone. So today's session I'm ending right now. So from next session onwards, try to join on time. Okay, so there is a 2 hour window where we can discuss from 5 to 7. So if you have any question, feel free to post in the that QA and I mean that discussion forum. And I suggest you guys to start interacting within the sessions. Okay, because that will be better if you simply talk rather than working in chats. Okay, so I'm ending today's session. We will see you next week. Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.